Hi everybody, so we're going to keep talking about solving systems of linear equations, and today we're going to talk about a method you probably haven't learned, Gaussian elimination. Okay, so the first thing we need to know if we're going to talk about this method is the terminology that goes with it. Okay, so a matrix is just a name for an array of numbers. Okay, so if you just arrange the numbers systematically, that's an array, okay, and that's called a matrix. Okay, so each number in the matrix is called an entry. Okay, so you have several different entries in a matrix. All right, so let's talk about why we would need an array of numbers when we're talking about systems of equations. Okay. Okay, so if you have a system of linear equations, you can form an array or a matrix using the coefficients and the solutions from that system. Okay, and when you form that matrix, that's called the associated augmented matrix. Okay, so let's look at more specifically how you would form that associated augmented matrix. Oops. Okay, so the first thing you're going to do is you're going to put the coefficients from the first equation in their own row. Okay, and then you're going to put a line, okay, and you put the solution from the first equation here. Okay, same row, okay, the rows correspond to the equations, but in its own column, okay, this is the augmented part. And then we're going to do the same thing for this one. So the coefficient here is 1, coefficient here is -1, okay, and then my solution is -5. Okay, so you can see the first row corresponds to the first equation, the second row corresponds to the second equation. Okay, this is my column that corresponds to x. This is my column that corresponds to y, and this is my augmented column, right, which is the solution column. Okay? All right, so let's do that with a bigger system of equations. Okay, So now I have 3 different variables, 1, 2, 3, okay? So I'm going to need 3 different columns here. So my coefficient here is 1, coefficient for y is 2, coefficient for z is -3. Okay, then I put the line and I start my augmented column, which is 4 solutions. So I put 1. Okay, now I'm going to do the same thing for the second equation. So my coefficient of x is 1. Now if you look, there's no y in this equation. Okay, which means the coefficient of y is 0. You do need to put something in that spot. Okay, so you put 0 in for y and then -2 for z, and 4 goes in my solution column. Then here I'll have 2, 1, -1, 9. Okay, again, each row corresponds to a different equation. So we have 1, 2, 3 equations, and each column corresponds to a different variable, x, y, z, and then solution column. Okay, all right. So let's talk about what are row operations. Okay. So there's really only 3 row operations. Okay, the first one is interchanging 2 of the rows, so you could just switch the first and second row, the second and third row, etc. Okay, the second one, okay, we could also multiply or divide a row by a constant, right, or a number. Okay, this might be helpful if you have fractional coefficients, right? You want to make nice whole numbers. Okay, and we'll see other cases where you might want a different reason to do this, but you can certainly do that. Okay, and then the third thing you can do is add a multiple of one row to another row. Okay. Now I want to talk really briefly about what these correspond to in terms of the equations. Okay, so if you are interchanging 2 rows, remember each row corresponds to its own equation. So you would just be reordering the equations. Okay, this one, multiply or divide a row by a number. Okay, remember that single row is one equation. So you're just multiplying the whole equation by one number or dividing the whole equation by one number. Okay, the last one, add a multiple of one row to another row. This is actually describing the act of doing combinations or elimination. Okay, so the reason I'm telling you what these are equivalent to is because none of these 3 things will change the solutions. Okay, so okay, these are all things that we're allowed to do with equations, right? You can reorder the equations, you can multiply or divide an equation by whatever number you want, except for 0, obviously. Okay, actually I'll put that in here. Okay, then you can add the multiple of one row to another row, right? That's describing elimination or combinations. We know that doesn't change the solutions, that gives us solutions. Okay, so we're actually going to use these row operations to solve. Okay, so let's talk about the process of Gaussian elimination. So Gaussian elimination is what people call an algorithm, right? It's a procedure that you do to a matrix to get solutions. Okay, so okay. So you're using elementary row operations and you want to put the matrix into a specific form, okay? So that form has ones on the diagonal, okay? And then it has zeros everywhere else, okay? Except not the augmented column, okay? You're not really concerned about how the augmented column looks while you're doing this procedure. You're really concerned with the part that's corresponding to the coefficients, okay? So for example, okay, for a 2 by 2 matrix, right, this is what you're looking for from the coefficient part, and then the augmented column can look like whatever you want, okay? Any numbers can go there. And then the same thing is going to happen here. Okay, you can see you have ones on the diagonal, all the other coefficient entries are 0, and then you have numbers here, okay? All right, so let's talk about how we're going to get it into that form, because Gaussian elimination is actually very specific, okay? So the first thing you're going to do is start with the top left corner. Okay. So you are going to use division / multiplication. Okay, to get a 1. Okay. Then the second thing you're going to do, okay, is use the top row to get all zeros in the first column below the first row. Okay. So first you're going to look at the top left entry, make it a 1, okay, and then you're going to use that 1 to eliminate the entries below it, okay. Then you're going to move to the next diagonal entry. Okay, and you're going to use division to get a 1. All right, then you're going to use that 1 to get all zeros below that diagonal entry. Okay, now depending on how big the matrix is, you're going to repeat steps 3 and 4 till you've done all diagonals and below. Okay, the process will naturally terminate because you'll run out of rows. Okay, and then you're going to eliminate, starting at the bottom right corner, Okay, you're going to eliminate above the diagonal entries. Okay. All right. So that sounds more confusing than it is. So let's look at an example. Okay. So the first thing we're going to do is form the augmented matrix. Okay. So we're going to start here with the top left entry, and we're going to use division to make this entry 1. Okay. So I'm going to divide my entire top row by 1. Or by 2, I'm sorry, to make a 1. Okay, so 0 divided by 2 is still 0. Okay, and I'm going to do nothing to the second row. Okay, so I just took the top row and I divided it by 2. Okay, so now, okay, I'm still looking at this entry. Okay, and I'm going to use my first row to eliminate this entry and get a 0. Okay, so if I want to add something, a multiple of this row to this one and get a 0, I would have to do, what can I add to 3 to get 0? Well, it has to be -3. So that means I need to multiply -3 times the first row and add it. Okay, so -3 times row 1. Okay, and then I'm going to add it to row 2. Okay, so -3 times 1 is -3. Oh, I'm not going to change my first row at all, so I'm just going to copy that down. Okay, so -3 times 1 is -3, plus 3 is 0. -3 times -1 is +3, plus 4 is 7. 0 times -3 is 0, plus 7 is 7. Okay, so now I have my diagonal entry as a 1, and below my diagonal is a 0. Okay, so that means I'm done with this first column. Then I'm going to move right 1 column, and I'm going to look at the diagonal entry. I want that diagonal entry to be a 1, so I'm going to divide by 7. So I don't change my first row at all. You're only doing one step at a time. Okay, and then I'm going to divide my second one by 7. Okay, so now you can see my diagonal entry is a 1. Okay, and there's nothing below my diagonal, so I don't need to do anything to make that 0. Okay, now there's no more diagonal entries, so that part of the process terminates. Okay, so that's the first component. You get the diagonal entries to 1, you get 0 below them. Okay, now we're going to move on to the second phase where you start at the bottom right, which is also this entry. Okay, and now you want to eliminate above that. Okay, so what could I add to -1 to get 0? Well, it'd have to be 1. Well, this is already 1, so I'm just going to add row 2 to row 1. Okay, so I'm not changing row 2 at all. Okay, and I'm just going to add this to row 1. So 1 plus -1 is 0. Oh, I filled this in because 0 plus 1 is 1. 1 plus -1 is 0. 1 plus 0 is 1. Okay, and now you can see that the left side, the part that corresponds to the coefficients, is in the form you want. 1 on the diagonal, 0 everywhere else. Okay, now I want you guys to remember what this means, right? This 1 means 1x, 0y, okay, equals 1. Okay, well, what does that really mean? X equals 1. Okay, then we're going to look at what the second row means. Remember, this is 0x plus 1y equals 1. So y is 1. Okay, so this is my solution. The solution is 1, 1. Okay, and that's why people use this process. Okay, once you have the left-hand side in this form with the 1s and 0s, the augmented column is the solution. Okay, let's look at another example. Okay, so the first thing we're going to do is form the augmented column, or the augmented matrix, sorry. Okay, now we're going to focus on the top left corner and make that a 1. It is a 1. Okay, so now we're going to move on to our second step, and we're going to get a 0 below that. Okay, so what multiple of 1 could I get to eliminate negative 2? Well, 2. So I'm going to do 2 times row 1. Okay, and then I'm going to add it to row 2. All right, so I'm not changing row 1 at all. Okay, then I'm going to do 2 times my first row and add it to my second row. So 2 times 1 is 2, plus negative 2 is 0, right? And that's what you're trying to do. 2 times 5 is 10, plus negative 7 is 3. 2 times 7 is 14, plus negative 5 is 9. Okay. All right, so now we're done with the first column. We have 1 and then 0. So we're going to move to the right and look at the next diagonal entry. It's a 3. We want it to be a 1, so we're going to divide that row by 3. So I'm not going to change. So I'm going to do row 2 divided by 3. Okay. Not changing my top row at all. Okay. And then I'm going to divide my second row by 3. All right. Okay. So now I have this entry is a 1 and there's nothing below it. Okay. And there's no more diagonal entries. So I'm done with the first phase where I'm doing diagonal and below, diagonal and below. Okay. Now I'm going to start here where I've boxed it, and I'm going to eliminate above that entry. Okay. I'm just copying it because I needed a new sheet of paper. So this is exactly what I had before. Okay, I'm going to start here, and I'm going to eliminate above that. Okay, so I'm not changing my second row at all. Okay, and I want to eliminate this position. Okay, so I'm going to need to multiply by negative 5. Okay, so this is going to be negative 5 times row 2, and I'm going to add that to row 1. Okay, so 0 times negative 5 is 0, plus 1 is 1. Okay, 1 times negative 5 is negative 5, plus 5 is 0. 3 times negative 5 is negative 15, plus 7 is negative 8. Okay. Now remember, once you have this in the specified form, the augmented column is the solution. So I can just read off my solutions, negative 8, comma 3. Okay. All right. Let's look at an example with a system of 3 equations and 3 variables. Oops. Okay, so the first thing we're going to do is just form our augmented matrix. Remember, because there's no x, we're putting a 0 in the x position. Okay. All right. So now we're going to start in the top left corner. Okay. And we're going to make that entry a 1. Okay. That entry is already a 1, so that's good. All right. Step 1 taken care of. Now we're going to look below that, and we want to make this a 0. Well, it is a 0. That's good. Okay. Now you want to make the last entry in this column also a 0. Okay. Once you make the diagonal entry 1, you want every entry below that to be a 0. Okay. So here, okay, I'm just going to take row 1 and I'm going to add it to row 3. Okay. So I'm not going to change my first row at all. I'm not going to change my second row at all. Okay, and I'm going to take my first row and add it here. So 1 plus -1 is 0. -2 plus 1 is -1. -3 plus 2 is -1. 0 plus 3 is 3. Okay, so now I'm done with my first column, and I can tell because the diagonal is 1 and everything below the diagonal is 0. Okay, so now I'm going to move here. Okay, and I'm going to use division to make this entry a 1. Okay, so I'm going to take row 2 and I'm going to divide it by 2. Okay, so I'm not changing my first row at all. Here I'm dividing by 2, so 0 divided by 2 is 0, 2 divided by 2 is 1, 1 divided by 2 is 1/2, okay, and -8 divided by 2 is -4. Okay, and I'm not changing this row at all. Okay, all right, so now I'm still looking at this entry. I want the entry below it to be 0. Okay, I'm going to use the second row to eliminate this row. Okay, so I'm going to take row 2 and I'm going to add it to row 3. Okay, not changing my first 2 rows at all. Okay, and then my third row, I'm going to add them. So 0 plus 0 is 0. 1 plus -1 is 0. 1/2 minus 1 is -1/2. Okay, and then -4 plus 3 is -1. Okay, now I'm done with this column because I have 1 on the diagonal. Okay, remember this is the diagonal, and then everything below that is 0. Okay, so I'm going to move to this entry. Okay, I want this entry to be a 1, so I'm going to divide it by -1/2. Okay, so I'm not changing my first row at all. Not changing my second row at all. Okay, and here I'm going to divide by -1/2. 0 divided by -1/2 is 0. 0 divided by -1/2 is 0. -1/2 divided by -1/2 is 1. Okay, and then -1 divided by -1/2 is going to be positive. Okay, and remember, dividing by 1/2 is the same as multiplying by 2. So I'm going to get a 2 there. Okay. All right. So now I'm done with the first phase. I have 1s on the diagonal, and everything below the diagonal is 0. Okay? All right. Now I'm going to start in the bottom right corner, okay? And I'm going to eliminate everything above the diagonal, okay? So if I want to eliminate this entry, I need to take row 3, okay? And I need to multiply it by -1 times -1/2, okay? And then I'm going to add it to row 2, okay? So I'm not going to change my last row at all. And I'm not going to change my first row at all. Okay. So 0 times -1/2 is 0, plus 0 is 0. 0 times -1/2 is 0, plus 1 is 1. Okay, that's why you're using the bottom row, because you're not going to mess up this part. Okay, so you can see I still have that nice stuff here that I want. Okay, now 1 times -1/2 is -1/2, plus 1/2 is 0. 2 times -1/2 is -1, plus -4 is -5. Okay. I'm still not done with this column though, right? Because I still have an entry above the diagonal that isn't 0. Okay, so I'm going to take row 3, right? When you're eliminating above the diagonal, you're always using this position. Okay, so I'm going to use row 3 times 3, and I'm going to add it to row 1 to get rid of that. Okay, not changing my last row at all. Not changing, oops, 0, 1, 0, -5, not changing that row at all. Okay, and now I'm going to add row 3 times 3 to my first row. So 0 times 3 is 0, plus 1 is 1. 0 times 3 is 0, plus -2 is -2. 1 times 3 is 3, plus -3 is 0. Okay, 2 times 3 is 6, plus 0 is 6. Okay, and now you can see I am done with this column because everything above the diagonal is 0. Okay, so I'm going to move back to this position. Okay, and I'm going to eliminate everything above that position using this one. Okay, so you're using this diagonal position to get rid of this -2. Okay, so I'm going to take row 2, right, because that's the row with that position that I'm interested in. Okay, and I'm going to try to eliminate this. So I'm going to multiply it by 2, and I'm going to add it to row 1. Okay, so I'm not changing this row at all. I'm not changing this row at all. Okay, and now I'm going to take this row and multiply it by 2 and add it. So 0 times 2 is 0, plus 1 is 1. Okay, 1 times 2 is 2, plus -2 is 0. 0 times 2 is 0, plus 0 is 0. -5 times 2 is -10, plus 6 is -4. Okay, and remember, once you have this in the diagonal form, so you can see the 1s on the diagonal, 0 everywhere else, your solution is over there in the augmented column. Okay, so there's my solution. All right, we'll do more examples of this in the next video, okay, and we'll do some examples where things come out slightly differently, but that's enough for now. I'll see you guys soon.